Hello there, I'm your host Dan Rojas. In this video, I'll be showing you how to make a high-end, energy-efficient softbox light from a 16:9 ratio Fresnel lens. This can be used for domestic lighting applications, taking quality pictures of something you might want to sell on the internet, or open the doors to a new career as a commercial photographer. These are MEZE headphones. I'll be using these for a future project that requires superior sound reproduction. They're the most comfortable headsets I've ever worn. The high-tech look combined with the beautiful high-gloss wood finish makes them a perfect subject for this video. Many of you are familiar with our custom-made Level 3 spot Fresnel lenses used for solar applications. This is what a real solar spot lens looks like. This is a 16:9 ratio TV lens salvaged from a rear projection TV. For this project, a crystal clear superpowered spot lens is not the best choice. Any typical TV lens will work, even a mid-grade spot lens of the standard 4:3 ratio commonly used by other YouTubers for solar videos. The reason a clear spot lens is not the best choice for this project has to do with light diffusion. While a true solar spot or linear lens allows for maximum light concentration patterns, the purpose of a TV screen is to diffuse the light, acting as an imaging screen. This is a perfect combination of Fresnel and Softbox technology. In this video, I'll be showing you the correct way to make a frame. While this technique has been covered in previous videos, I've made more than 17,000 of these for various framing projects, so this, in my opinion, is the best process. Start by ripping a 2x4 down the center. Once you have two rails, lower your saw blade and make a 1/2 inch cut. Repeat for both rails, then flip the wood and run it through the saw again. If you did it correctly, your insert and rail should fit like a puzzle piece. With the insert and rail firmly held together, cut a starting 45-degree angle cut on a chop saw, tapering towards the insert rail side. Using only the rail, measure and mark the shortest length of your lens. At your chop saw, line the insert up with the frame rail and simultaneously cut to the inner mark you made. Both the insert and the rail should match up. Repeat this process for the long rail. Since you need two sets of rails and inserts for the length and the width, for the second cut, line the rail ends up with each other. Place in position and hold the bottom piece of wood with the chop saw. Remove the top rail that we're using as a guide, firmly hold the rail and insert in place, then cut the final 45-degree cut. Always remember never to place your hands inside this part of the saw, and should something jam or fall, just let it go. Do not try and grab for anything while the power tool is running and you'll be okay. Using a syringe filled with glue, little hack idea, add wood glue to the end of the long rail. Drill a 1/8 inch pilot hole and finish with a 2.5 inch wood screw, making sure that you do not drive out the side. Correct building skills should produce a rail that is firm even before the glue sets. Repeat this step so you have two big L's, then glue and screw them together. You should have a nice square frame. Insert your Fresnel lens with the Fresnel side facing up or towards the insert side. If you did a real good job, the lumber stamps should match up perfectly when adding your insert rails. Using 1¼ inch fine drywall screws, place two very strong clamps on the frame rail to hold the insert in place. Here's hack number 2. Pre-drill using the screws. Start to drive the screw in, then stop and reverse. This strips out the insert rail. Then you drive the screw all the way in. Here it is again. This little trick prevents unwanted sawdust from pre-drilling with a standard drill bit from getting stuck inside the Fresnel grooves. Boom, boom, bam. And if you did it correctly, your miter should look something like this. I'm using two 10-watt bright white LED lights for this process. By measuring a piece of scrap rail for the length and width, I'm making a smaller box for these LED lights to sit in. Because the back of the structure will be supporting all of the weight of the light box, I ripped a rail in a full 2x4 using the same method outlined previously in this video. This 12-inch by 18-inch large area frame is a perfect fit for our light bank. Since this Fresnel lens is 58 inches corner to corner, I cut 4 rails 26 inches with matching 50-degree angles. The sharper the angle, the shorter your rail will be. This allows for a more shallow box profile. This depth is optimal for these two lights. Lightly tack the 4 rails in place with a single screw for position only. Once you are happy with the final configuration, add wood glue and use 2 screws on each leg to prevent twisting, as this part of the design is an important weight supporter that may be overhead for some applications. Carefully make a long pilot hole at an angle so you pierce the large support frame and the support rail at the same time. Then drive a 3.5-inch wood screw in for all 4 corners. Glue is also a good idea. If you did everything correctly, it should look something like this and be rock solid with no squeaking or wobbling. The next step is to insert the light bank, holding it in place with a couple of wood screws. This allows for quick changing for color temperature and light replacement should one go out. These energy-efficient 10-watt bright white LED lights produce amazing directional light output. This is a big 5,000-watt production light used by the Walt Disney Film Company in a previous life. Using powerful neodymium magnets, I replaced the high-powered bulb with 4 of these LED lights 2 years ago. I also placed a couple of these inside of another stage light. These last a very long time. These bulbs come in standard 120 volt and 240 volt configurations for domestic usage like the ones I use for my can lights. They also come in 12 volt configurations like the lights I'm using for this Softbox, allowing for many hours of energy efficient mobile lighting from a small 12 volt battery power supply. While some DC versions of these lights come with the traditional red and black wire, many of these DC lights use European brown, blue, and green striped wiring. For the DC versions, the blue is usually the positive or red terminal, and the brown wire is usually the black or negative terminal. The green is not used for 12 volt. These configurations can vary widely depending on the manufacturer, so check the wiring insert included with the light, and if you are new to electrical wiring, have an expert electrician help you. This project took me less than an hour to build and makes good use of all those Fresnel lenses that do not work well for concentrated solar applications. There are links to some of the items used in this video in the description area below. I'm your host, Dan Rojas. Thank you for watching and enjoy our videos.